Hey, like I said, we're doing about 2 days of the circle stuff. Today I'm going to try and go through all the parts and all the different ways you can maybe see angles with circles. And then on Monday I'll probably go through all the segment stuff and also go through like the equation of a circle so you can at least see it. Even though the equation of a circle is pretty much Pythagorean theorem. No, like graphing the equation of a circle, not circumference and things like that. That's another stuff we could cover. Okay, so we're going to start with just the parts of a circle. Even though I think at some point we've kind of gone through little bits of this here and there. The most basic thing for a circle is that you have a center point, and by definition, a circle is just a set of points that are a distance from the center, like a set distance from the center. Meaning that essentially this is not like a solid arc, it's just a whole bunch of points that are really tight together. Okay, and every single one of these points is the same distance from the center, which of course is the radius. Alright, now the things you guys need to know definition-wise, at least as a very basic, is you need to know center, you need to know chord, you need to know diameter, you need to know radius, you need to know secant and tangent. Alright? So from top to bottom there, center, this is a point, okay, such as the point that's C that's up there. There are other points that they might reference, but the other points would either just say on the interior or on the exterior. On the interior just means it's inside the circle, exterior means it's on the outside. These three right here, chord, diameter, and radius, these are all different segments. Meaning that you're going to have endpoints, like you can have arrows go on, but these all have a set length to them. Okay, there's a starting point and a stopping point. These two right here, chord and diameter, they have to touch the circle. The only difference is the diameter has to go through the center, a chord does not. So these two right here, we'll say touch the circle. By that I mean the endpoints are on the circle. I don't really have a lot of room there. Okay, so if I was just to identify a chord, it would be something like that right there. So segment AB would be considered just a chord. Again, a diameter is also a chord, but since it passes through the center and it essentially cuts your circle in half, you're going to identify it as a diameter just so that other properties pop up with it. So, say I did that one. We'll do EF. Okay? So since I know that point C was what I called the center, I know EF is a diameter. Alright, then of course, you know the relationship between diameter and radius? Yes or no? What is it? So radius is half the diameter. So if I know where the diameter is, I can just look at the point from where it hits the circle to the center to identify a radius. Okay, so you got EC being a radius and CF being a radius. Alright? And that accounts for all the segments you guys would see. These two right here, a secant and a tangent, these are both going to be lines there, meaning that when you actually write this out, the notation, you need to make sure that you're having notation for lines and segments so you can differentiate between the two. A secant line, this one right here, this one is a line that passes through the circle, meaning that part of the line has to be on the inside of it. So if I just took this segment here, AB, and extended it out, segment AB is still a chord, but line AB would be considered a secant line. And again, the only difference between that notation and the one up there is I have that listed as a segment and that is a line. Okay, so secants have to pass through on the inside of the circle. All right, a tangent line, this thing right here intersects the circle once. Meaning that what a tangent line is, it's like if you physically had a circle there and you physically had a line and you just rested the line on the circle, like you balanced it on it somewhere. That would be a tangent line. So if I had a, let's say this point right here, okay, and I said that one right there is only touching at that one specific point, which probably isn't, I drew that a little wonky, but still, if I said it's only touching in that one point, this line right here, which we'll call like M. Oh my gosh, line. Okay, that line down there would be called a tangent line. All right, and this point where it touches, that point where it touches is called the point of tangency. Okay, now, like I said, you guys just need to be familiar with the terms. Like you should be able to identify these. If I were to give you a picture with a whole bunch of lines in there, and I could say, find me a radius, you should be able to look at the center, look at a point that's on the circle, and connect it to a radius. Okay, so now again, these three right here, segments. That's a point. Those two are lines. So when you write notation, again, you have to make sure you write out. If you're talking about a tangent, put the little line symbol above the two letters. Secant, put the little line symbol above the two letters. Okay? All right. Now, everything else we talk about here is going to be dealing with different ways you can see angles in circles. The way that I kind of identify them, there's going to be 4 different things you're looking at. Okay? As long as you can identify the vertex of the angle, you should be able to determine how to find the measure of that angle according to where the vertex is labeled. And there's going to be a different kind of formula for each one. Okay? Oh, I guess before that, let me do this because I keep forgetting we're skipping around so much. The other thing is an arc. We talked about this probably in passing, but an arc, guys, just remember, is just a part of the actual circle. Okay? So, and when you write arcs out, you write them with like a little tiny, like a on top of two or three letters, depending on what you're looking at. Okay? So let me erase this before I get into all that side note here. You have minor arcs, and then you got major arcs. Which, did we talk about this? I can't remember. God, all the years run together. So, minor arcs, guys, these are less than half of a circle. And these are more than. But you can't go beyond a full circle. Like you cut it off at 360 degrees. So if I was looking at measurement-wise, minor arcs are from 0 to 180, not including 0 because there's no arc there. If it's 0, it's just a point. And 180 degrees would be exactly half a circle, which is neither of these. And a major arc is from 180 to 360. Again, not being exactly 360 because that's a full circle. And not being exactly 180 because that's half. And your half circles, guys, are semicircles. Those are the 180, right? This is the half circle stuff, okay? When you write out minor arcs, you always use 2 letters. So like AB looks like it's kind of small, yeah? So looking at the picture over there, I would say AB is a minor arc. If you see 2 letters, generally speaking, you're going to have a measurement less than 180 that goes with it. Because again, this is all related to a circle being 360 degrees. And you figuring out portions that are either greater than or less than, less than 1/2 or greater than 1/2 of that specific number, the 180. Major arcs with this, you're generally going to see those with 3 letters. You can't really do major arcs with 2 because, again, 2 letters means that you're looking for something less than half a circle. So let's say I went over here and I looked at, what did I use it? D. If I looked at this arc right here from here all the way around to there, so from A to F, but from A to F in this direction, because we already said that's a diameter, so that's greater than half a circle. If I were to identify that one right there, that would be written as ADF, because D kind of gives me the direction I'm going. The 2 letters that you use are always at the ends or the end points, so I know I started at A, I ended at F, but I went in the direction that included D, so that's why I have to have the D in there. Whereas if I just wrote the 2 letters, I would be talking about it going in that direction because it's shorter. Yeah. Okay? 2 letters always means go the shortest path. Just think about it that way.
So if you're trying to get from A to E,
Like the long way?
yeah, you have to do A, E, and E.
No, you just use 3 letters. Like I would just, if I wanted to go from A to E, but go the long way, I would just pick one other letter that's on that arc. Like F would work. I could do B, E. That other letter just tells you that, like, start at A, travel through that one first, and then end up at the other one.
So it would have to be D or F.
Or D. A, D, E would still be the same one. Because if I started here, again, because you can't go, if I know I'm starting here and ending here, I'm not going to go here to here, because I'm not going to cross the other endpoint first. All right, I'm going to erase all this. Okay, so now with the angles. All right, so like I said, there's kind of 4 situations that can happen here. And again, it's all a matter of identifying where the vertex is, because as long as you can find the vertex, you can kind of do some work to figure out what the angle measures are. Okay? All right, so your situations are you're going to have a vertex for your angle at the center. You can have a vertex attached to the circle. You can have a vertex inside the circle, but not the center. Okay, because if it was inside the circle, not the center, it would revert back to the first one. And then you can also have a vertex outside the circle. Okay? Now, each one of those situations you would treat differently, but that's really the only things that could happen. All right? Now, like a vertex at the center would be you dealing with an angle like that one right there. I'm just calling it angle 1. It's not 1 degree. It's just angle 1. If you have a vertex at the center, what you would see is that the arc and the angle are equal. Now, when I reference arc here, it means that if you were to like look at your angle and kind of trace the angle out, whatever arc is in between the sides is what I'm considering referencing here. So if I knew that instead of that being a 1, like if I put this as like 70 degrees, like if I said this angle is 70 degrees, that means that this arc out here takes up 70 degrees of the entire circle. Those are the easiest to work with because they're always going to be equal. All you just have to do is trace out the 2 sides, and whatever arc it goes through is going to be equal to it. Okay? For this one here, vertex on the circle, be more something that looks like that. Okay, so again, looking at that angle right there. I'm just calling angle 1. If it's on the circle, so here's my vertex. This means, when I say on, I mean it's connected to the circle. Like here it's connected to the center point. This one's on the circle. If this happens, the way you deal with it is the angle is going to be 1/2 the arc. Okay, so if if I knew, so again, well, sorry, the arc that I'm looking at is the one that's in between the two sides. So if I told you from here to here was like 50 degrees, which is not, it doesn't make any sense with that one. This one here would be 25 degrees. Okay, they always have to be in that relationship. The angle's never going to be bigger than the arc that it opens up to. Okay? As a side note to this, if you have, and what this is called, sorry, just in case they say it, this is called an inscribed angle. If you inscribe something, that means you're putting it in the shape, but it's also having vertices that are connected to it, right? When we did an inscribed circle with like triangles, remember it was like inside the triangle, but it also was connected to the triangle, but it was completely inside it. If you have one of these things that open up to a diameter, like if I gave you that little drawing, I said AB is a diameter, and they have like a triangle or like an angle drawn to the endpoints, like if I added that in there, this angle here will always be 90 degrees. They're not always going to give you an arc measure with that because it's just assumed you understand the diameter cuts a circle in half, and half of a circle is always 180. And then if you do half of 180, you get the 90 that's there. Okay, next one is inside a circle but not at the center. So this is going to be where you've got two chords kind of crossing like that inside a circle somewhere. So that if I look at, here's an intersection point, I have an angle here that is inside the circle, but it's not connected to the center, so I can't just make it equal to the arc. With this one here, the way this works is that your angle it's 1/2 of the arc. It's just the fact that if I look at this angle here, if I trace out the sides, I've got this arc here, but I also have to include this one over here. Because these two angles here, where this angle is and where that angle is, where I have angles 1 and 2, remember those are vertical angles, right? And vertical angles have to be equal to each other. So I have to take into account both of those arcs. So what you're going to do is you just add those up. So you're basically taking the average of those two arcs together. All right, and then for the last one, so outside of the circle might be something like this, where I'm looking at that angle right there. Again, just like this one right here, you've got two arcs that you have to take into account for. But I'm not going to add them because that would be this situation here. If you look at it in relation to these two arcs, that's a really small angle. So the way you deal with this is you're going to subtract them. Okay, but I'm going to write this as big arc minus small arc. Okay? And what I'm referencing is like if I looked at these two again, if I trace out the sides of the angles, this one right here, this is like the big arc. This one in here is the small one. Okay? So if I did problems just to have some with those last two on there. Okay, like here's I'll use this picture here. We got A, B, C, D, and E. So we'll say find measure of angle ACB. And I'll tell you that the measure of arc AB is, I don't know, what's it, about 30. And the measure of DE can be, I don't know. If this is 30, how big do you think that is? 50. Sounds good to me. Okay? All right, so I want you to find that angle right there. So now again, like I said, you need to kind of go through a check of seeing which one it lines up to, which is this one. Because my angle is at the inside of the circle. It's not at the center, because the center should be somewhere over there, so I know it's not the center. So that means I need to extend the sides of that angle out and realize that I'm going to take this arc and this one and add them together. So if I want to find x here, where I put the x for the measure of ACB, I'm going to do 1/2 of 30 plus 50. What's half of 30 plus 50? 40. So 40 degrees right there. I could also give you an angle measure and ask you to find an arc. It doesn't matter because you understand, treat these things, especially these two down here, as like formulas. I've got 3 places to put numbers. If I give you 2 of them, you can find the missing one. Same thing here. I could tell you the angle. I could tell you the big arc. You can find the small one. Okay. Let me do one with that bottom one here. I'm gonna do like 2 with this one. All right, so we'll do one with just the angle. How big you think that arc is up there? 70? How big is this one?
30.
God, if that's 70, this is like, no, it's less than 30. 20 makes a little bit more sense. Is it? No, it's not. Okay, so again, your check needs to be, they want me to find an angle. The angle's on the outside of the circle. That's where my vertex is. So I'm going to take my angle equals 1/2 the big arc, which is 70, minus the small one. So what's 70 minus 20? And what's half of 50? Okay, now, just throw you a little bit of a wrinkle with that one right there. And I'm not saying the problems you guys have are going to be this straightforward. You have to do a little bit of work. What's that? Yeah. Okay. So now, I'm still going to be finding the value of the angle here. So x. But what I'm going to give you here, guys, is I'll tell you that the measure of arc ABC, which is a major arc because it's bigger than half the circle, is 200 degrees. That's all you get. Okay? Now, the thing is, and these are probably going to be given to you this way majority of the time. Not always, but majority. Since my vertex is still on the outside, I know I'm doing the angle equals 1/2 the big arc minus the small one. Okay? And they're giving me, and again, the 2 arcs I look at are the ones in between the angles. So I got one here, which I have as 200 degrees, and the other one is right there. Which they don't give you, but you can figure it out. It's what? Why is it 160? Yeah, because this is 360, the whole circle minus the one that they tell you, because the 2 arcs together are going to make a complete circle. So I know that number there is 160. So when I do this, it's just going to be 1/2 of 200 minus 160. 40, so this is 20. There you go. Okay? All right. Everything that you guys are working through today, like that I have on that paper, are going to be related to this in some way. So I'll leave it up there. Okay? But like I said, it's not necessarily going to be as straightforward, so you're going to have to do a little bit of work with some of this stuff. Oh, let me see. Oh, the one last thing. Let me get rid of this. Is an inscribed quadrilateral. Well, not necessarily a square. Okay? So here's the thing. If you've got an inscribed quadrilateral, the way you're going to work with these is all these vertices are on the circle. So they're like half of the arcs they open up to. They're not going to give you arcs. What these generally are going to do is they're going to have like an x there, and they'll give you like 100 over there, and they'll say find the value of x. Okay? Now I could set up a couple equations using the angle stuff over there and figure it out, but what's always going to happen is those are opposite angles. Correct? Right? In terms of that quadrilateral, those are opposite each other. They will always be supplementary, meaning that they add up to 180. So if I know one of them's 100, the one directly opposite it better be 80, or else it's not supplementary. These two right here will also have to add up to 180. Okay? The whole reason is they're both inscribed angles, and if you connect both of those together, they make a complete circle. Half of 360 is still 180, but I'm not, you don't necessarily need to worry about proving it all out. Just keep in mind that if you've got like a four-sided figure inside a circle, and they give you one of the angles that are opposite each other and ask you to find the other one, just subtract the number from 180. Okay, they have to add up to 180 across from each other. They're not equal, because if you do that, you're going to get numbers that are bigger than 360 inside that quadrilateral, which aren't possible. Okay? All right. So your guys' assignment is on the computer.